This distance education examination, which was done in April 2025, Phi 1000 Introductory Physics, Kwame Nkrumah University. All right, should be very simple. Okay, it's distance education, by the way. All right, let's look at question 1. A car accelerates uniformly from rest at 3 meters per second squared. What is its velocity after 5 seconds? All right, of course, for this one, we just use the first equation of motion. It's from rest, meaning initial velocity is 0. Our acceleration is 3, time is 5. So we get V as 15 meters per second. Which of the Newton laws states that an object will remain at rest or in uniform motion unless acted upon by an external force? That's the first law of motion. A ball is thrown horizontally from a 20-meter high, ignoring air resistance. How long does it take to reach the ground? We take gravity as 9.81 meters per second squared. All right, ladies and gentlemen, so we're going to use this equation of motion. All right, so we're looking for what? Time. So S is 20, which is displacement. And remember, this part is always 0 because it's coming from somewhere like this and it's dropping like that. All right, meaning initial velocity is 0, so everything is 0. So just limit the half, 9.81, then t, we don't know, square it. All right, so meaning we'll be getting all right, so this means 20. Of course, here when you divide, you get 4.9 something. Yeah. Or just cross multiply, you have t squared. This is 40 over 9.81. Of course, you do that. You have your t as 2.02 something like that. So where are we going? On 2 there. The force required to maintain an object in uniform circular motion is called, that is the centripetal force. A 5 kg object moving at 10 meters per second collides with a stationary object of 3 kg. If they stick together, what is their final velocity? So which type of collision is this? Is perfect inelastic collision, all right, where 2 objects stick together, momentum is conserved, but kinetic energy is not conserved, but they move together. Okay, so meaning m1 v1 plus m2 v2 should be equal to m1 plus m2 multiplied by what? V. V will be common because they have stuck together and they are moving together. What are we looking for? We are looking at their final velocity. All right, so the first mass is 5 multiplied by 10. Then 3 times 0. It is 0 here. It is stationary, meaning its initial velocity was 0. So we add 5 plus 3 and multiply by V. So we get 50 and 0 here. So we get 50 is equal to, this is 8 V over 8 over 8. So what is V? Our V is 6.25. That. The rotational equivalent of a force is torque. That is just, remember how we call it moment of the force, but when it comes to rotational motion, there's also moment taking place there, but we call it torque. All right, according to Bernoulli's principle, what happens to pressure in a fluid as its velocity increases? Now, all right, so with Bernoulli's principle, what we need to understand that, what does this actually state? It says that for an inviscid fluid, meaning an increase in the speed of the fluid occurs simultaneously with a decrease in static pressure, meaning if speed increases, pressure decreases. The inverse proportion, right? Which of the following is an example of a simple harmonic motion? A car moving at constant speed, a pendulum oscillating at small angles, a ball rolling down an incline, a satellite orbiting the Earth. Well, first of all, we need to understand what simple harmonic motion is, the SHM. Now, for simple harmonic motion to take place, there must be a restoring force, and this restoring force must be proportional to the displacement. All right, remember Hooke's law kind of stuff. Meaning a pendulum it undergoes a simple motion. All right, now a pendulum okay, it goes forward, back, forward, back. That is simple motion. All right, it's simple harmonic, meaning because it oscillates after a certain period of time, it goes back like that. It's an oscillatory type of motion. All right, and you understand to say a pendulum it makes an angle of approximately less than 15 degrees. Yeah, somewhere there. The ideal gas law is given by there. A heat engine operates between two reservoirs at 500 kelvins and 300 kelvins. What is the maximum theoretical efficiency? All right, so maximum theoretical efficiency, all right, is given by 1 minus the cold temperature over the temperature which is hot. So you get 1 minus, so 300K, which is cold, and the hot one is 500K. So, so here we get 1 minus 0.6, right? Because this is 0 and 0, yeah, 0.6. So we get 0.4. Now 0.4 as a percentage, you get 40%. Okay, so we are now going 40%. All right, section A is done.